So come again. I was talking about BPDU. So as I've told you, these are the messages which are used by STP to share the STP information with each other in order to elect a switch and detect loops. And the most common messages are called as hello BPDUs, all right, which include the following information. So the hello messages or have BPDUs are going to have root switch ID, all right, senders switch ID. What's the switch ID of sender? Sender's root cost. What's the cost? And then hello maximum average or age. Maximum age, comma, forward delay timers. So this is the information which is in one BPDU, Bridge Protocol Data Unit. Okay?
Okay.
Now, electing, as I've told you, I have given you the demonstration of electing a root bridge. So electing the root, not root bridge, I'm always using the wrong things. Electing the root switch in STP. As I've told you, there are two ways, either through the priority or through the MAC address. So STP process works by default on Cisco switches and begins with the root switch selection. Whenever you, as I've told you, so it works by default. Whenever you connect 2, 3, 4, 5 switches together, at the same time when they get connected, they just, first thing what they do is they begin with the root switch selection. So the selection is based on bridge IDs, BIDs, sent in the BPDUs. So each switch that participates in STP will have 8-byte switch ID that comprises the following fields. 2-byte priority field, PRIORETY priority field. By default, all switches have the priority of 32,760. As I've told you just before some time, 32,768. So this value can be changed using configuration commands, which I'm going to tell you later on. And also, these are called as, the election is based on bridge IDs. These are called as BIDs, okay? Now, this is how the election is going to happen. So the election is based on BIDs. These are called as bridge IDs. Sent in BPDUs. When you send or share the information, as I've told you, using the BPDU, there are bridge IDs, or you can say switch IDs. Each switch is going to participate in STP, will have 8-byte switch ID, as I've told you, and that switch ID will be comprised of 2-byte priority field plus 6-byte system ID. So that's 8. So 6-bit system. So a value based on the MAC address of each switch. So that's a value based on MAC address. So as I've told you, a switch with the lowest BID will become a root switch with the lowest number, meaning better priority, right? So for example, we will draw a topology here, 1, 2, another switches here, and they are connected. This is switch S2, this is switch S1, this is switch S3. Now, the MAC address of this is, for example, 00004.9A.9A47. Then at last, this is the priority. Then 006.2A5A.7919. then 0090.2b65.4ba8. Okay. In this topology, the switch with the lower BID wins, since the default, or since by default all switches have the BID priority of 32,768. The second comparison has to be made with the lowest MAC address. So this is MAC address, this is MAC address, this is, as you know that we have not changed the priority. By default, all these switches are having the same priority, which is 32768, right? So based on that, there will be a tie when the election will happen. Correct?
Yes.
Yes.
Second thing is we need to compare the MAC address. Now look into the MAC address 1, 2, and 3. This is going to start from 0.0.4. This is going to start with 0.0.6. This is going to start with 0.0.9.0. But you can see the priority here. I mean, you can see the complete MAC address. So in our example, SW1 has the lowest MAC address and becomes the root switch. You can see this is highest, this is highest, this is the topmost, this is then second one, and this is 0004. Am I correct? Or even if you
Yes.
check here, it is 1039, it's 7919, it is 4BA8. So this one is having the lowest MAC address. This is gonna be the root switch. Got it?
Yes.
So for simplicity, all ports on switches in the example above are assigned to VLAN. For example, VLAN first. Also note that STA adds the VLAN number to the priority value. When you talk about ST, it's gonna STP or STA, it's going to add the value number to the priority value. So all switches actually have BID priority of 32,769. It adds one value to that. When you will have VLAN, so there will be a VLAN number attached to that. So VLAN first, so that it's going to add that number. That means one will be added to this plus one. So it will become 32,769 then. When you talk about VLANs, by default, when you will not be having the VLANs, then it's going to be only 3276. But even by default, all the switches are in all the interfaces are VLAN or under the VLAN first, then only it's going to be, even then it will have one more number of that VLAN. So that number will be 1. So it will have the priority as, all the switches will be having the priority as 32,769. So now, if you don't want the election should happen based on the MAC addresses, because we don't know, MAC addresses can be anything, but if we want this S2 to be the root switch, right?
Yes.
Now what we have to do, let's go through it. So if you wanted to influence the election process, you change the BID priority to lower value on a switch you would like to become root. So command to change the priority. The lowest will be always the root switch. So if you want, so priority, wait a sec, so priority. So the command will simply say spanning tree VLAN ID, the ID that you might be using. So VLAN ID priority. Oh my gosh. PRIORITY priority, then the value that you want. For example, you can set as 1000 only, right? So we'll go to switch S2 and we'll go through spanning tree VLAN ID. What's the VLAN ID? Whether it's 1, it can be 15, it can be 20, priority, this. For example, VLAN ID 1. By default, we are under the VLAN 1. So my switch is under the VLAN 1. Priority, for example, 224. So that's the thing. How do you do that? So let's go through it. I'm going to take one particular switch here. And the Cisco packet tracer. I will take one switch, 1, 2, 3, even 4. I will add cables to them. Okay, this is switch S1, this is S2, this is S3, and this is S4. Go to CLI, enable configure terminal. First of all, show crypto DHCP history host interfaces, MAC address table, monitor, port security privilege, running configuration, spanning tree. Show spanning tree, detail interface summary, VLAN switch trees. Detail. You can see here, designated bridge has a priority 32,769. I told you it is basically 32,768, but one is basically the VLAN ID value, which is 1. So that became 32,769. Are you understanding? So VLAN 00 is executing the IEEE compatible spanning tree protocol. Bridge identifier has priority this, you can see. System ID is 1, so this is the MAC address. Configure hello time 2, maximum age is 20, forward delay is 15, current to root has priority this. Root port is 2, pause is this, cost of root pause is 19, topology change flag not set. All right, so port 1, port 2, and so on. This is detail. All right, so root port is 2, cost of root path is 19, topology flag not set. And then now simply I will go and configure this particular switch one. If you want this to be your root switch, we'll go to VLAN, switch your spanning tree VLAN first, for example, first, and then priority. I will say the priority is 225. Hit enter. But allowed values, bridge priority must be increased. Bridge priority must be in increment of 4096. Oh, allowed values are like, so then we can say it should be increment of 4096. All right, so 4096, we can say first value 4096, the lowest one, then hit enter. That's it. Now this is going to be your root switch. So show spanning, spanning tree. We can summary of port states of VLAN. Alhamdulillah, sorry. Active. Root, you can see show spanning tree active. You can see spanning tree enabled protocol IEEE. Root ID is priority 4096. Address is this. The bridge is not, the bridge is the root, you can see. All right, with this, you can check whether this is root or not. Hello time 2 seconds, maximum age is 20 seconds, forward delay is this. Bridge priority is this. And then if you check the bridge priority of other switches using the same, show spanning tree active, you can see here it will be mentioned root ID priority address is this 4097, cost is 19. Hello, this priority, this, it's not set as. If you talk about this one, what's the difference, which is added here? You can see it's written here, the bridge is, this bridge is the root. Open here. It's not written anything over here. So there's a route ID, it's 4097. Here we have 40, but priority is set as 4096. Why it's showing as 4? Oh, one is basically the VLAN ID. As I've told you, it will be then 4097. Okay.
Okay.
Yeah. So it will be then 4097. This bridge is the root, but then it becomes here also port first 40 Ethernet this 4097. Again, it's going to change the MAC address. Then here also, what you have to do then, by default, it's 32. Why it's not giving by default? Priority here, yes, sorry. This is root ID basically. Bridge ID is here, 3. And when you talk about this switch, we have this priority, 4097. Root ID is here. We need to go through the bridge ID. So it's 4097 for this switch. It's 32796 for every switch. It should be same. When you go over here, so you can go to enables, show spanning tree active. You can see here the priority is same, and even here we'll say these are all non-switch or non-root switches. Enable show spanning tree active, and you can see the same priority. Only this switch is the one where I have changed the priority, and this is the root bridge. Okay. You can check more information, show spanning tree, and then use help. Summary interface. We can use now summary. You can check it out. So this is the summary of it. Active report and active interfaces. So here is root bridge for by default. Extended system ID is enabled. Port fast default is disabled. Port fast guard default is disabled. Ether channels mascot disabled. UP link fast, backbone fast, configured. Path cost method used is very short. So this is about the priority, and this is how you can influence the root switch, how you can change your settings to root switch. So how to elect a root switch by changing the priority in STP. So by default, as I've told you, every switch is having this STP enable. We are helping, it's going to help us to prevent the loops, and it's going to select the root switch first. And based on that, it will be having all the things included.
No.
Yep. Wait a sec. Let me take the attendance. Let me take the attendance. It's very important. Okay, so is it clear?
Yes.
Now, after that, we have another. There was the evolution of STP, or STP is the new protocol that we do have, and it stands for rapid spanning tree protocol. So it's an evolution of STP, and it was originally introduced as IEEE 802.1W. It was not D. So it was introduced as IEEE 802.1W standard, and in 2004, IEEE decided to replace STP with Rstp in 802.1 standard, D standard. Finally, in 2011, in the IEEE decided to move all the Rstp details into 802.1q standard. All right. So there is one more standard which came after this, which is 801.q. I remember this thing, Rstp is backwards compatible with STP, and there are many similarities between the two protocols. For example, the root switch is elected using the same setup rules in both protocols, okay? And root ports are selected with the same rules as well as designated port on LAN segments. Both STP and Rstp place each port in either forwarding or blocking state. I mean, there are mostly all these similarities which we have already studied, and even I have taught you all those things. And I told you there is what is forwarding state and what's blocking state. The blocking state in Rstp is called as discarding state. Now, instead of blocking state, this is the difference. In STP, we used to have forwarding state and we used to have blocking state. In Rstp, we used to have forwarding state and we used to have discarding state. This is the difference. So we used to have discarding state instead of forwarding state. Okay. However, there are several differences between STP and Rstp. Rstp enables faster convergence times than STP, usually within just a couple of seconds. So in terms of convergence, Rstp is better than STP. STP ports or port status, listening, blocking, and disabled are merged into single state in Rstp. So STP port status, which are like listening, blocking, and disabled, they are basically merged into a single state in Rstp, and that's called as discarding state. Okay, blocking state was having three status: listening, blocking, and disabling. But in Rstp, it's just simply discarding state. STP features two port types, root and designated port, but Rstp adds two additional ports, alternate and backup port. We used to have two more ports in Rstp, alternate and backup. With STP, the root switch generates and sends hellos or BPDUs to other switches, which are then relayed by the non-switches. With Rstp, each switch can generate its own hellos. That's the main thing. In STP, the root switch generates the hellos to other switches, but here Rstp is going to create its hellos. Like in routing, we used to have hellos from every particular switch. So over here also, every particular switch will be in the hello packet state. So in order to avoid loops, Rstp has placed one port on, you can see the same example. So that port will be, placed in the alternative state, not in the blocking state. You understanding? So the port example that I have given you here, so this port in this particular topology, if you have this Rstp enabled, so it will just put that port in the alternate state. The port will not process or forward any frames except the Rstp messages. However, if the root port on SW3 fails, the alternative port will rapidly become the root port and start forwarding frames. All right, but in STP, it's automatically going to, unblock this port and then start sending the matches to root port. But here it's set as alternative because if this port stopped working, if there is a problem in this particular channel or in this particular switch, then automatically we have the alternative here and it will start sending frames. Configuring Rstp. Nowadays, most of the Cisco switches are using Rstp by default. Rstp prevents frame looping out of the box and no additional configuration is necessary. So to check whether a switch runs Rstp, you can use the show spanning tree. There is no need of this configuration. So you can use show spanning tree. Command to check, and there will be, I guess, so if in the switch you are going to check whether Rstp is enabled or not, we'll go through it. Enable configure terminal. Oh, exit. First of all, we need to check using show spanning tree. Priority is this. It's gonna just designate it forward say 19. Priority 1 into role access. So if it's not, but how can we check it's not? Spanning tree enabled protocol IEEE. Root bridge and interfaces are there. But if it's not, then if you wanted to check in or if you want to enable it, so we can use spanning tree in the configuration mode. We have to use, so to enable the Rstp, we use spanning tree mode rapid-pvst. Hit enter. That's the command which will help us to enable this particular protocol instead of other. Are you here with me?
Yes.
Yeah, so there is no need of these configurations. That's why I'm going a bit fast. Where am I? Yeah, so if it's not enabled, so to enable the Rstp, we have to go through this command. And now again, when you check, exit it, show spanning tree. How can we check? Here you can see now, spanning tree enabled protocol Rstp. So by default, this switch was not having the Rstp enabled. It was just IEEE. All right. So Rstp spanning tree enabled protocol Rstp. So root ID is this. Root ID is the same, and this is the root bridge now, but it's going to have the features of Rstp. So this is how we can turn on. But it has been said that nowadays most of the Cisco switches, the newer switches, are having by default now it has been replaced with Rstp, not with STP. So if it's not, so you do not have to worry. You can go through this command, spanning tree mode rapid-pvst, and if you want to verify, then you can use show spanning tree and you will get the information. Okay?
Okay.
Okay.
I guess this is enough for today. I'm exhausted, and in the next class, we are going to start with ACLs. Okay? Once again, we will be working with routers. This was all about switches. I taught you about what switches are. I taught you about VLANs, and I taught you about VLAN trunking protocol, which was very important. And this is STP and Rstp. They are by default enabled. So only what you need to do is, in order to set a particular switch as root switch, you need to change the priority. You need to remember that switches having by default the priority 32,768 plus one value of VLAN ID, even in Rstp. So by default, when you have a new switch, you can have Rstp enabled, but no problem, it's not enabled. You can go through it. You can just enable it using the command which I have given you. Okay, is everything clear about switching?
Yes.
Is everything clear about routing?
Yes.
So now we are moving towards security. It's not more about security here. We have just ACLs and then we have NAT. So these are the two topics which we're going to start from Saturday. And inshallah, these are security topics through which we can protect our network. All right, we can just permit or allow other people to visit our website or visit our network. Okay, so those things we're going to discuss in the next class, inshallah. But this is enough for today. Okay.
Okay.
All right. I took your attendance, so I will see you in the next class on Saturday.
Inshallah.
Until that, bye-bye. Take care. Stay safe.
You too.
Allah Hafiz.